So let's talk about for loops. In Python, for loops are used to iterate over a sequence, such as a list, a tuple, a string, or other iterable objects, or to execute a block of code a specific number of times. The general syntax for a quote-unquote for loop in Python is for item in sequence. Underneath, we're going to have the code block to execute. This block will run for each item in the sequence, in other words, for each iteration of the for loop. We're going to use item, the object item, to access the current element in the sequence. The indentation is crucial in Python to define the block of code inside the loop. So everything that's indented once underneath the for loop is the body of the loop and will be executed each iteration of the loop. So let's do a quick breakdown of each part of the for loop. The for loop starts the loop declaration. Item is a variable that represents the current element in the iteration. You can choose any valid variable name here. It helps to name the variable something that is indicative of what the work that you're trying to do or what it represents in the sequence. In specifies the iterable object sequence over which the loop will iterate. Sequence itself is the collection of items over which the loop iterates. It can be a list, a tuple, a string, a dictionary, a set, or any other iterable object in Python. The colon indicates the beginning of the indented block of code that will execute for each iteration. And then, once again, the indented block of code, it's the block of code that's going to execute for each item in the sequence. This code is executed repeatedly until the sequence is exhausted. So let's go over some examples. So here we're iterating over a list. A list is called fruits. That list contains 3 objects, apple, banana, and cherry. So for fruit in fruits, we'll say print out that fruit. So our output is going to be, in our first iteration, fruit will be apple. It'll print out apple. Second iteration, the fruit will be banana. It'll print out banana. Third iteration, the fruit will be cherry. It'll print out cherry. The code indentation here indicates that the body of the loop is just print fruit. So once it prints the object in fruits, it finishes the iteration and it loops to the next object. Another example is iterating over a string. In this case, our object or our item is going to be char, right, which just indicates that it's going to be a character. We could have named this char, we could have named this character, we could have named this any random name, but we're using char here because when we iterate over a string, we're actually going to be iterating over the different characters that make up the string. So we've given the variable a name like char because it properly indicates what the object is within the sequence. So here we're going to print out each character, car, character, char, however you want to pronounce it, in the sequence hello. So our output will be H in the first iteration, E in the second iteration, L, and O, the following iterations. Next example, we're going to iterate over a range for a specific number of times. So for I in range 1 through 5, keep in mind that range is going to be from 1 to 4 because the second parameter in range, so we have our 2 parameters, 1 and 5, the second parameter is exclusive, so we're not going to include it in our iteration. So it'll be 1 to 5. So this range will basically act as though it were a list of integers that will contain 1, 2, 3, and 4. So as we print out every item in that range, we'll get 1, 2, 3, and 4. We can also use enumerate to access indices and items. So in this case, we're going to have a list, again, of 3 objects, strings representing Alice, Bob, and Charlie. So for index name in enumerate, we're going to be getting the index of the object as well as the object itself. Again, these are variable names that we are assigning. They don't have any particular meaning on how this is going to behave, right? They don't have any impact on how it's going to behave. No matter what you name these variables, it will always behave the same way, where the first item in enumerate is going to be the index of the object, and the second item will always be the object itself within the list. So this will be 0, index 0, name Alice, index 1, name Bob, index 2, name Charlie. Here we're using an f string, So we can just, within the curly braces, add our variables that we want to print out. It'll automatically cast the index as a string so that we can print it out properly. And we'll get our output in the first iteration, index 0 plus 1 is Alice, or excuse me, in 0 plus 1 is 1 for our index, and then the name is Alice. And it'll iterate to 2 Bob and 3 Charlie. The reason that we've added a plus 1 here is not because we have to, right? But because we want to make the print statement make sense. Person 0 doesn't make a ton of sense in regular nomenclature, right? In regular discussions. Even though Python is zero-based indexing, that may not necessarily make sense to an audience that isn't Python savvy, right? So we want to add 1 to the index so that it behaves like people are accustomed to person 1, person 2, person 3, instead of person 0, 1, and 2. We can iterate over a dictionary, right, which is just keys and items, keys or items as well. So here we have a dictionary where the first object is name and John, both strings. Second object is age and 30, a string and an integer. Third object, city and New York, string and string. So we can iterate over just the keys in a dictionary, right? And so what happens here is that we're going to print out the key, which will be name, age, and city. And then we'll use that key itself to access the value in the dictionary. So we're saying get name, use it to access the name value in the person dictionary, which will be John. So when we print out for the first iteration key and the key within person, we get name and John. The key is age in the second iteration, and that key, when accessed within person, will bring us back the value 30. And then the last iteration, city in New York. Alternatively, we can use the items method of every dictionary to iterate over key value pairs. Items will just return a tuple of key and the value. And so what we're doing is we're unpacking it in this line. We're saying for every tuple in person, get the first value, get the second value, and print them out. In this case, we're giving them the key and value names to the variables because that's what they represent in the tuples that are generated by items, but they could be any variable name that you'd like. When we print that out, we get the same as above, name John, age 30, and city New York. And so we move on to one of the more complex aspects of for loops, which are nested for loops. And all that means is that it's a for loop within a for loop. So remember, in a for loop, in a basic for loop, we would iterate over 1 through 4, right? 4 is exclusive, so we would really be iterating 1, 2, and 3. Now what happens is when we have a nested for loop, in each iteration of our original outer for loop, we're going to do another for loop to fruition. So what does that mean? This would just iterate over 1, 2, and 3. We'll just do an iteration 3 times, and it would execute a block of code 3 times, right? So you can imagine the outer for loop is executing 3 times. 1 to 4 exclusive, so it's really 1, 2, 3. Execute code 3 times. So what is the code that's going to execute 3 times? It's another for loop. So if we look at this for loop, this is going to iterate over 1 through 3 as well, right? But it's going to print the value in the outer iteration, which is I, times the value in the inner iteration, which will be 1, 2, 3 as well, right? We're printing it with a space, and then we're printing it with a new line at the end of each iteration so that we can go down. So let's talk about our first iteration here. We're at iteration 1, I is equal to 1. It's the first value in range. So when we get into our second, the body, right, of the outer for loop, we have another for loop where j is going to be equal to 1, 2, and 3. We're still in the first iteration of the outer for loop, so I will be 1 this entire for loop until this for loop is done. So when we print the first iteration of this inner for loop, I is 1 times 1, we get 1. It's printed out with a space. So that's what this prints. Then we go to the second iteration of this inner for loop. J now is equal to 2, so j times 1 is 2. We print it out with a space. And then we go to our third and final iteration of the inner for loop where j is equal to 3. J 3 times 1 is equal to 3 with a space. We finish this entire for loop in the inner for loop. And so now we iterate to the next part of the outer loop where I is going to be equal to 2. We're in our second iteration of the outer for loop, I is equal to 2, and now we do the inner for loop again, right? Because it's every iteration of the outer for loop executes the body each time. So now we're the second iteration of the outer for loop, so we're going to execute the body again. I is equal to 2, j will once again reset and will be equal to 1 because this is a new for loop as far as the code is concerned. So j is equal to 1, I is equal to 2, so we get 2 here. Now j will be, in the next iteration of the inner for loop, j will be equal to 2, 2 times 2 is 4. Next iteration, j is equal to 3, 3 times 2 is 6. We finish the complete iteration of this for loop again, and so now we print a new line, and we're here, and now we're in the final iteration of the outer loop, where I is equal to 3. We go into the body, we're going to execute this for loop to fruition, so it'll be 3 times 1 is 3, 3 times 2 is 6, 3 times 2, times 3, is 9. And we're done with the nested loop. Some things to keep in mind. The range function is commonly used to generate a sequence of numbers to iterate over. The for loop iterates over each item in the specified sequence until the sequence is exhausted. You can use the break statement to exit a loop prematurely, or the continue statement to skip the rest of the current iteration and proceed to the next one. Python relies on indentation to define the block of code inside the loop. All statements indented at the same level are considered part of the loop body.